Hello everyone, today we're going to look at calculating ion concentration in solutions. How these problems work is you're going to be given some sort of an ionic compound that is fully dissolved in water, and you're going to be tasked with finding the concentration of one or both species. So here I have a very simple ionic compound, potassium bromide, which I can write down as KBr solid, which when dissolved in water will dissociate into potassium ions, which I can write as K positive in its aqueous state, and bromide ions, which I can write down as Br negative in its aqueous state. It's always important to start with a balanced chemical formula, so let's just check to see if it's balanced. We have one potassium on the left, one potassium on the right, one bromine on the left, one bromine on the right. So we're good to go. Now, these problems can seem really intimidating at first, but really it just boils down to three simple steps. And the first step is to find the moles. Now, when finding the moles, you're either going to be given a mass or a concentration in your question to work with. I've put both of them down here, just that we can work through both types of problems, but realize, of course, you'll only be given one piece of information. If we're given the mass, then we need to have the molar mass of KBr in order to solve our problem. We can consult our periodic table to find our molar mass. Here we have one potassium and one bromine. Potassium has a molar mass of approximately 39.10 grams per mole, and your number might be slightly different than mine. And our bromine has a molar mass of about 79.10 grams per mole. Now, if we put that in our calculator, we'll get a combined molar mass for potassium bromide, which is 119.0 grams per mole. Okay, now that we have our molar mass, we can easily solve for our moles. We have moles, N is equal to mass, little m, over molar mass, big M, and we just have to substitute in our information. So we have a mass of 16.0 grams of KBr, and we have a combined molar mass of 119.0 grams per mole. If we type that into our calculator, we will get an approximate mole value of 0.134 moles of KBr. Alternatively, we might be given concentration first. And so we have a concentration here of 0.223 moles per liter. We have our formula that concentration is equal to moles divided by volume. However, here we actually have to solve for the moles. So we're going to have to manipulate our formula. I like to start by highlighting what I want and seeing what's currently attached to it. So currently our moles is being divided by our volume. So we can use opposite operations by multiplying this side by our volume, multiplying this side by our volume, and we will get a new formula that moles, N, is equal to concentration multiplied by volume. Now all we have to do is substitute in our information. We have a concentration of 0.223 moles per liter, and we have a volume of 600 milliliters. Now, in order for our liters to cancel out, we need to make sure that our volume is also written in liters. We have 600 milliliters, and since there is 1,000 milliliters for every liter, that will give us 0.600 liters of water. Now you'll see that the 2 liters cancel out, and we are left with moles, and we're left with an approximate mole value of 0.134 moles of KBr solid. All right, let's move on to the second step. So our second step is to multiply by the subscript. Now the subscript is those small numbers that are written after each element to indicate how many of them there are. In the case of potassium bromide, there are these sort of invisible ones, these implied ones that are written after each one to indicate that we have one of each. So in this case, that's what we're going to use. Let's say that we want to calculate the concentration of potassium ions in our solution. Well, first we have to find out the amount of moles of potassium ions in our solution. And to do that, we can set up a molar ratio. We have 0.134 moles of potassium bromide, which I can then multiply and say that, okay, for every 1 mole of potassium ions that I have in my solution, I have 1 mole of potassium bromide. Which makes sense, because if we look up at our balanced formula, we can see that for every 1 potassium bromide over here, I have 1 potassium. And so that explains our ratio. Now, a 1-to-1 ratio, we're going to see that our potassium bromide will cancel out, and we are left with 0.134 moles of potassium ions in our solution. Now our last step is to divide by the volume. We have our formula here, concentration, C, is equal to moles N divided by V for volume. In this case, we can substitute in our information. We just discovered that we have 0.134 moles of potassium ions, and we have a volume which we have already calculated to be 0.600 liters. Now, if you were to calculate that in milliliters, you would get a concentration in moles per milliliter, but because we're looking at moles per liter as the standard units for concentration, we need to make sure to convert our volume into liters. And we end up with a concentration of 0.223 moles per liter. All right, so next let's do a chemistry problem that is a little bit more difficult and maybe does not involve 1-to-1 ratios. Here we go. All right, it's time to do our final chemistry example. Now, the first thing you're probably thinking is, why is there a weird burger written beneath the problem? Well, we'll get there. It'll make sense. Don't worry. Let's start by just reading the problem. It says 46.0 grams of magnesium chloride is dissolved in 0.280 liters of water. What is the concentration of chloride ions in this solution? Okay, so in this problem, they've given us a mass to work with of magnesium chloride. Now, magnesium chloride, we have to make sure we're balancing that out. So magnesium has a charge of 2 positive, and you can see that on your periodic table, while chloride has a charge of 1 negative, which means that in order to have a neutral compound, we need to have 2 chlorines. So we're going to end up with magnesium chloride, like so. Now, if I were to write out a balanced chemical equation, I have magnesium chloride, solid, which, when placed into the 0.280 liters of water, becomes magnesium 2 positive in its aqueous state and chlorine negative in its aqueous state. Now, before we move on, we have to make sure that our equation is balanced. We have 1 magnesium on the left, 1 magnesium on the right, great. 2 chlorines on the left, but only 1 chlorine on the right. So we have to make sure that we put a 2 in front of this. Now, the burger, it'll make sense later. We're just going to leave it for now, but you might already be seeing a little bit of a correspondence there. So if I have a mass of 46.0 grams, we know that the first step is to find the moles. To find the moles, we need to have the molar mass represented by big M, which will be equal to the molar mass of magnesium, which you can get off the periodic table to be 24.30 grams per mole. and the molar mass of 2 chlorine, so we have to put a 2 in front of it, which each one has a molar mass of 35.45 grams per mole. If we type that into our calculator, we're going to get a molar mass. Let me just write that out here. Molar mass is equal to 95.20 grams per mole. All right, now we have our formula from earlier that moles is equal to small m mass over big M molar mass. Here we have small m is 46.0 grams divided by our big M, which is 95.20 grams per mole. And we get our moles, which is 0.483, taking into account sig digs, moles of magnesium chloride. Okay, so that was our first step. Our second step is to multiply by our subscript. Here we have a subscript of 2 for chlorine. So if we were to write this down, we have 0.483 moles of MgCl2 solid, but for every 1 mole of MgCl2, we have 2 moles of chlorine. 2 moles of chlorine ions. Now, why is that? Well, let's take a look at our hamburger example. One hamburger is made from a hamburger patty and 2 buns. So that means that I have 2 buns for every 1 hamburger I have. So just for every 1 magnesium chloride I need to have 2 chlorine negatives, which means I have twice as much chlorine negatives as the amount of magnesium chlorides that I have. So we can cancel out our MgCl2, and we're left with our moles of chlorine negative, which is 0.966 moles. Our final step is to find our concentration. So we know that concentration is equal to moles divided by volume. We have our moles of Cl negative. We have 0.966 moles of Cl negative aqueous in our volume of 0.280 liters of water. Now, notice that we are given our volume in liters, so we don't need to convert it. If we type that into our calculator, we will get our concentration of approximately 3.45 moles per liter for our chlorine negative ions in solution. So there you have it. That is how you solve for ion concentration in solutions, starting with either mass or starting with concentration of the solution and then looking for the ions themselves. Thanks for watching. If you enjoyed the video, make sure to give us a thumbs up. It really helps. And if you really enjoyed it, make sure you sub to the channel. See you next time.